So in lesson, we have been learning about moles. We've learned that 1 mole is equivalent to 6.022 by 10 to the 23 particles. We've learned that these particles could be atoms, or these particles could be molecules. You've been introduced to a conversion factor, which is 6.022 by 10 to the 23 particles all over a mole. Okay, and that makes sense because 1 mole is 6.022 by 10 to the 23. So when we're doing our questions, there's always going to be something we have in the question and something we want in the answer. And we have to find or use this conversion factor. Apologies for that. We are going to have to arrange this conversion factor to kind of get rid of what we have to give us what we want, if that makes sense. So if we have a look at question 1, it tells us we have 4.4 moles of neon, and I want to find out how many atoms. So straight away, I just need to confirm that if I do this piece of maths on neon, I will have my answer in atoms, and that is the case. So I need to look at my conversion factor, and I have 2 options. I can leave the conversion factor as it is. So if I put 6.02 by 10 to the 23, and this will be in atoms, all over 1 mole. Does this get rid of the mole to give us atoms? And if we look at it as a piece of maths, it means I get to cancel these guys out, and when I multiply 4.4 by 6.022 by 10 to the 23, I am going to get atoms. So the conversion factor, as we used it, works perfectly. I don't need to flip it around to change it. So I put those into my calculator, and when I do this, I get 2.64968 by 10 to the 24. And in Leaving Cert now, we are doing everything to 4 significant figures. So these are 4 significant figures. But when I'm looking at it, I need to have a peek at what comes next. And because it's a 6 that comes after the 9, I have to round up. So 2.650 by 10 to the 24 atoms is the final answer that I would get here. So that was question 1. If we have a look at question 2 now. So again, we have something we have something that we want, and we need to arrange our conversion factor to get rid of, in this case. So let's have a look at what we have. We have 1.204 by 10 to the 24 molecules. That's what we have. We want from our question moles. So again, we have got to arrange our conversion factor to get rid of molecules for ourselves. So if I put in our conversion factor as it stands, 6.022 by 10 to the 24 molecules, and I'm putting that over mole. If I look at here and here, so I have molecules and molecules, this doesn't work because I don't get rid of my molecules from here so that I can get moles in my final answer. So that's not going to work. So I have to now rearrange my conversion factor. So I'm going to do a little bit of erasing here. Make it small. Okay, so that one didn't work. So now I turn it upside down and I write mole, and I write 6.022 by 10 to the 23 molecules. And when I look across my line now, molecules cancels here, and it leaves me with what I want. So if I was putting this into my calculator, I would be putting it in as 1.204 by 10 to the 24 and recognizing that that's 6.022 over 10 to the by 10 to the 23. 0. Not great video now. 1.204 exponential 24 divided by 6.022 exponential 23. You might get a funny fraction. You just have to click your SD button and it's going to give me 1.9993 moles. Again, for the SEC, we're looking for 4 significant figures. I have to look at what comes after my 4th significant figure. It's only a 3. So my final answer for this guy is 1.999 moles. So in all of these now questions, we have been trying to use the conversion factor to get rid of the unit that we have. The reason why I'm being insistent on conversion factors is to make sure that you are answering the question that is being asked. So I'm going to scoot to question 6 for you just to show you what I mean. So in question 6, we have the thing that we have is 2 moles of water. Okay, the thing that we want is atoms. Okay, straight away I have to recognize that water is a molecule. So there's something that I'm going to have to do or to recognize at the very end of my piece of maths. So if I am using this as molecules, I need to arrange my conversion factor to get rid of moles for myself. And we have already worked out that if I go 6.022 by 10 to the 23 molecules, because that's what water is, I am going to put that over mole, and now I should be able to cancel this mole and this mole here, and the answer that I'm going to get is going to be 1.2044 by 10 to the 24 molecules of water. So I'm looking for 4 significant figures. I'm looking at the number that comes after the 4. So at the moment, 1.204 by 10 to the 24 molecules of water works. But it didn't answer my question. There will be some candidates that would stop here now with this as their value. They wouldn't go any further with it because they wouldn't have put in their units, and they wouldn't have recognized that actually my answer is in molecules, but the question asked me about atoms. So some clever candidates will recognize that they could have, if they so wished, multiplied their answer here by 3, and that would have actually gotten to them where they want. Where are they getting that 3 from? So H2O, when we've done our balancing equations, this is how we've written it. That is the same as saying 3 atoms. So there's 2 H's and 1 O in here. So to convert molecules to atoms, you would multiply your answer by 3. So 1.204 by 10 to the 24 multiplied by 3 is going to give me 3.6132 by 10 to the 24. I want 3 significant figures. I look at the end of it, and when I am done now, 3.613 by 10 to the 24 atoms. Okay, so that is a question, I call it that it has a kick. So the layout is really important because you need to recognize that in this instance, final answer needed to be in atoms. And if you didn't write in what your units are here, then maybe you wouldn't recognize that. Okay, so I'm going to go back up, just scoot back up and over, and we'll just try a question 3 and question 4 just to see them. So in question 3, it says how many something in 3 moles of sulfuric acid. So what we want is 3 moles. It wants you now to work out sulfuric acid, so you should know the formula. It's H2SO4. That means we're dealing with molecules. The question says, so we must want molecules way over here, so what we want, oh, I did that wrong, apologies. So this is our have and this is our want. So we have over here 3 moles. We want molecules because the H2SO4 is molecules. So we can put in our conversion factor one way and see does it work. 6.022 by 10 to the 23 molecules all over a mole. When I look at this, it works because this and this will cancel out for me. So I then plug everything into my calculator, and when I do that, it should give me 1.8066 by 10 to the 24, and it is going to be in molecules. Again, 4 significant figures is to here. I have to look at what comes next. I have a 6 as my 5th significant figure. That will make everything round up 1. So my final answer is going to be 1.807 by 10 to the 24 molecules. If we have a look at question 4, what do we have? We have 1.2 by 10 to the 19 something of water. So we know water is H2O, so this is in molecules. So this is just testing you. Do you know what are molecules, what are atoms? We want, way over here, we want moles. So we can put in our conversion factor and we'll see which way it will work. So 6.022 by 10 to the 23 molecules all over moles. I'm using my conversion factor to get rid of what I have. I have molecules. Arranging my conversion factor this way does not get rid of molecules. It kind of squares my molecules, so that's not going to work. So in reality, the conversion factor must look like this. So now my molecules are over the line here and they're under the line here, and I'm going to be left with moles when I do my piece of maths. So 6.02 by 10 to the 23. So 1.2, by 10 to the 19 divided by 6.022 exponential 23. And when I've done that, it is going to give me, now depending on your calculator, so 19926 by 10 to the 24 by 10 to the minus 5. So it's a small number. You look at 4 significant figures, you look at the figure that comes after it, it's going to be 1.993 by 10 to the minus 5 moles. Final answer. So I'm hoping now that this is making sense. So we're looking at our conversion factor to get rid of what we have and to give us what we want. So the last question up there is question 5. The thing that we want is molecules. It's telling us we have 0.5, so what we have is 0.5 moles of chlorine. It wants you to recognize that chlorine is Cl2, so chlorine is a molecule. We put in our conversion factor, so we'll try it the way it is on our card, 6.022 by 10 to the 23 molecules, all over a mole. When we work it this way, it works. I can cancel out mole above and below the line, and then I put it into my calculator, and it should be 3.011 by 10 to the 23, and that is going to be in molecules. I only have 4 significant figures in my answer, so this one works. So for our little summary, we are trying to arrange the conversion factor so that we're getting rid of what we have And what I mean by that is that we can cancel out the units to get what we want. So if we've done our cancelling out, then we should have the units for what we want left. We need to be aware that when we're given information, that the given information we need to recognize, is it about atoms or is it about molecules? And is there then from this a little kick to the end of the question? Okay, and again, if you set up every time using all of your units, it will be very obvious whether or not you have answered the question asked. So the last little bit that I'm going to say is that if we are trying to find atoms, it is going to be, you're going to essentially multiply moles by Avogadro's number, 6.02 by 10 to the 23 particles. And if you are trying to find, atoms or molecules, I apologize. If you are trying then to find moles using Avogadro's number, it would be the number of atoms or molecules in your question, and you would be putting that over Avogadro's number. So 6.022 by 10 to the 23, and again that might be atoms, but it could be molecules. So that is what we have been doing exceptionally briefly. But as I say, you keep talking to yourself. You're just trying to arrange your conversion factor to get rid of what we have in terms of its units to get the units for what we want. And that is that.